Stoichiometry mole-to-mole problems. What you'll be doing in this worksheet is determining how many moles of one substance would be needed to react with or produce a certain number of moles of another substance. So what we're going to do here is we're going to be setting up another problem, kind of like what we were doing in our mole to mass problems, where we have a given and then we're going to multiply it by a conversion factor to see what it is that we need. Now in your reading materials there is an example that looks like a recipe, and let me show you what that looks like here. So in our mole to mole stoichiometry notes we have something here that looks like a recipe, and it's a made-up recipe, but we're going to use it. It says 1 cup of water plus 2 cups of mix will yield 8 pancakes. Well, I'm not always going to want to make 8 pancakes. Sometimes I'll want less than 8, sometimes more than 8. Well, let's say that I want to make 16 pancakes. Well, I know that that's double the number of pancakes that I need. So in this case, I could just double my recipe. As I know from cooking, I'll have to double my recipe to double the amount of food that I make. But what I want to have you guys practice doing is how we set this up when we don't have this nice easy recipe. Now I'll go ahead and use the recipe example to set up this first problem that we're going to do. So I wanted to make 16 pancakes, but in my equation, in my recipe, that's not what I actually have. I end up with 8 pancakes. So I'm going to compare my actual balanced equation to what I want to get to see how much of something else it would take me. And in this case I'm going to solve for cups of water. I know if I wanted 8 pancakes I would use 1 cup of water. 8 pancakes for 1 cup of water. So if I wanted 16 pancakes I would set this up like so. I put my 16 pancakes, which I know is what I want to end up with, and I make my crosshatch, and I know that if I have pancakes on top I need pancakes on bottom, and from my reaction here to get 8 pancakes I would need 1 cup of water. So I have 1 cup correlating with 8 pancakes here. So I'm going to take my 16 times 1 cup of water divided by 8 to get the 2 cups of water that I need. 16 times 1 divided by 8 gives me 2. So just like I said I knew I would need to double my recipe to double my number of pancakes, I'd set this up in a way that I get that same answer that I need. Now let's look at how that is going to be set up for an actual chemical reaction. I have 4Al plus 3O2 yields 2Al2O3. It asks me how many moles of Al2O3 would be produced by the reaction of 12 moles of Al. So here's my given, because I see a number. 12 moles of Al is my given. So I'm going to put 12 moles of Al in my upper left hand corner because that's my given. Now I set up my crosshatch, and since I have moles of Al on top I want moles of Al on bottom. So I'm going to go up here and find my Al. There it is. And I have 4 moles of Al in my actual reaction. 4 moles of Al. And it asks me how many moles of Al2O3 would be produced. So here's my Al2O3, and 2 moles would be produced by this reaction. So 2 moles Al2O3 is what would actually be produced in my balanced equation the way it is up here. So I've put my given, I've put my 2 correlating amounts from my reaction, and I then multiply across the top and divide by the bottom. 12 times 2 gives me 24, divided by 4 is 6 moles of Al2O3 would be produced if I had 12 moles of Al. So let's set up the first one on your paper the same way. It says how many moles of hydrogen are needed to completely react with 2 moles of nitrogen. I've already underlined my given, 2 moles of nitrogen. So I'm going to write that out, 2 moles, and I look up here to see what nitrogen looks like. Here's nitrogen, but it's in a compound, so this is not just pure nitrogen. So I'm going to look over here at my N2, that's only nitrogen. So it's written as N2, 2 moles N2 is what I'm given, 2 moles nitrogen. And then I set up my crosshatch. Since I have moles of N2 on top, I want moles of N2 on bottom, and I'm going to look at my equation here the way it's written. So in this case, I only have 1 mole of N2 because there's no number in this spot. If there's no number, it's understood to be 1. So I have 1 mole of N2 in my balanced equation. I'm going to compare that with what I'm trying to solve for, which is how many moles of hydrogen. So here's my hydrogen. Remember again, hydrogen is here, but this isn't a compound, so it's not pure hydrogen. So I have 3 moles of hydrogen, and hydrogen is being written as H2 because it's a diatomic. 3 moles of hydrogen. So I've set up how many moles of nitrogen and hydrogen are in the balanced equation. I set up my given that I want to find out from how much would react with 2 moles of N2, not just the 1 mole. And I'm going to multiply across the top and divide by the bottom now that my moles of N2 have canceled out and I'm left with what I'm looking for, which is moles of hydrogen. So 2 times 3 will give me 6, divided by 1 is still 6. So my answer is 6 moles of hydrogen. And that is a 2. It's hard to see, I know. So I've set this up in such a way that I put my given here in the left-hand corner and then set up my 2 parts of my equation that are asked about in the question. Set up the rest of these the same way. Put your given on the top, compare the 2 things that you're looking for. I want you to pay attention here, potassium chlorate, 8 or ite ending, you want to look at your polyatomic ion chart. So find potassium chlorate for this one and make sure that you've set up this equation correctly. And if you do get stuck or still have any questions on how to do this, please come and ask.